Hello guys. My name's Ray. I'm also an assistant professor in the computer science department. So, a brief introduction about myself is that I mainly work on two topics. The first one is about infrastructure, which is exactly what I gonna talk today. Another topic is refer to the long-term memory and long context issue. Basically, enable generative AI to can process longer information and more or large chunk of information. Okay, so today I will talk about one very interesting but often got neglected problem in the community is like numerical precision. So usually speaking, no matter if you want to train a model or an inference model, you usually need to rely on the software and hardware stack, right? Usually speaking, most of us we rely on the PyTorch plus NVIDIA GPUs. So this stack, if you are familiar with the NVIDIA GPU, you will notice that this stack actually they are increasingly rely on the low precision arithmetic, like 16-bit or even 5-bit. Oh, sorry, or even 8-bit. In the latest generation of NVIDIA GPU, they are pushing towards the NVFP4 numerical format. That is only 4-bit per numerics. But and also, if you don't use them, it is just super slow and the lack of the infrastructure support. And I want to mention one very interesting problem associated with this software and hardware stack is the numerical issues. So here, I know many of you guys are working on the physical informed neural network. So I know in the physical informed neural network, there are one thing called the failure patterns or the collapse. So for example, you can train the model in FP32 refer to the floating point 32 bit. So you can train the model and you can see the loss just dropped around 0, but the accuracy doesn't change much. So you can see the accuracy just gets stuck. So many people, they think this is an algorithm design problem, but it turns out it's just a numerical precision problem. So the long story short, why this happens is that in many optimizers, you got some convergence criteria, right? So for example, the consecutive to run, their difference is very small, then you just stop the optimization. But the problem is that if you are using the lower precision and the neural network, they got some complicated mapping, and they will, for example, you cannot imagine how the error is propagated and finally lead to early stop of your optimization process or over optimization of your process. So one very simple solution is that you can just use higher precision for your PIN, but the trade-off is that it is very expensive. So this is one, and another one is I'm actively working on is that. So not sure whether you guys are aware of this problem. So usually speaking, no matter what kind of Gen AI, their inference process is not deterministic. By deterministic, I mean, if you control the random set, you control everything, but it still can return you the same response given the same prompt. So for example, this is pretty problematic in the task involving like explanation, because for many tasks, we only care about the final accuracy. So the accuracy is like a reduced metric. You reduce, you get the accuracy reduced from many test samples, right? But in many cases, you don't just care about the accuracy. You also care about, okay, whether the response makes sense to me or not. But in this case, ideally you want to have a token by token or a word by word identical result, but this rarely happens, or even not possible in practice without changing your infrastructure. But fortunately, the thing is that we made it. I will release one blog regarding this part soon. So I try to make the package that make the workload is entirely deterministic. And one related problem to the deterministic is reinforcement learning collapse problem. So actually, if you are using reinforcement learning, it often got crushed, and it just got crushed because of the numerical mismatch problem. And I also built support for the AI for Science workload, make it free from the failures just caused by the system metric or system issues. And yeah, I also attached one screenshot from the thinking machine lab. They just released one blog talking in details why the inference is not deterministic, even though you control everything. Okay, so that's it. I'm actively seeking a collaboration with domain experts who want to build easy to use tools and a package for the AI for science communities. And also, if you are struggle with the failures or run-to-run variance of your models, you can contact me. I can talk about it, why it happens, and what are the possible solutions to it.
And that's a naive question on that image, right? There you assign probability for each word. The next image. You show the non-deterministic nature.
Yeah.
But this probability distribution itself is something deterministic, right? The outcome you select which is probabilistic, but this distribution is a prediction. In essence, it's also still a deterministic output if I have full access to those rates and probability. Is that commonly accepted the concept?
So yeah, basically you are right. So non-deterministic is because, for example, in the probability distribution, you assign each token a probability to be sampled, right? So by non-deterministic, I mean if you run the forward pass twice and the probability assigned to each token, they are different. That's the problem. So it's not because of the sampling process. The sampling process itself, you can make it deterministic. The problem is inside the model. There are some operations like matrix multiplications. These operations is not deterministic.
Well, in other words, if I build a large enough output sample, that is very determined, right? And my result, as if I repeat my input many times, I will build an example of output. That distribution is purely deterministic and well described.
I want to make sure by deterministic, I mean you got identical results across, for example, 2 or 3 independent runs. No matter, for example, you run it 5 times or 6 times, you just got only one output. That's what I call deterministic. So this is not a concept related to the distribution.
Like, I think maybe another word is repeatable. It's not.
Repeatability.
Repeatability, reproducibility.
Reproducibility. So without this, you can think it in this way. So for example, you got your own result on your own computer. Other guys, they download your code, run the code on their computers, and they got completely different numbers compared to your numbers reported.
I guess the essence is because output of large language model or generative model is probabilistic. So you can only sample a field with a few tries.
Yes. But without this problem, for example, if you say that your random set is 42 and then you sample it twice, they stay the same. I hope it's clear.
It's also saying it's conditioned on the hardware. If you have 32-bit chip or 64-bit chip, your results will be.
Let's do one more question.
Yeah, because so this like non-repeatable issue is that because of like the numerical accuracy, or is because of the network structure? Like, for example, there's some batch norm. I'm sure it's not batch norm, right? Some batch norm you need to like make it fixed. When you do inference, then you get like the same output or
Actually, the answer is more lower level. It's related to the IEEE 754 numerical format. So basically, if you use this numerical format, you got rounding errors between your floating point arithmetic, and if the order change, the results are different. That's the root cause.